Hello, I'm James Blackman, editor with Enterprise IoT Insights. I'm back with you to introduce Colin Campbell, who is Senior Vice President of Wireless and Digital Services at Cambridge Consultants. Colin is going to present a case study on the work with SmartSky networks to deliver fast, resilient connectivity at 600 miles an hour and 30,000 feet in the air, which sounds amazing. I will rejoin at the end for questions, but for now, over to you, Colin.
Thanks, James. Thank you for that intro, and thank you for this opportunity to talk to you about a use case that is really close to my heart. You'll see a bit more of that in the coming deck. I've worked with SmartSky for the last 6 years or so, helping them develop this technology of theirs. I'm based in Boston, in our Boston office, serving our kind of North American markets. We are a global organization with development offices in Cambridge and Boston, Cambridge, UK, that is. The reason we're presenting this today is that it's a specific example of customization, but it's really to get the thought in your heads how you can customize technology so you don't have to be limited by the constraints that current technology gives you. You can think outside the box. You can choose parameters that you want to customize to and develop a solution that's specific to your use case. So this is just one use case where that was done, and really the whole idea behind this is unlocking the value in private networks. So this is something that as a business we have done countless times for many clients, where there's complex use cases where we're creating private networks to deliver business value to our clients. So whether that's controlling thousands of bots with millisecond latency and high reliability in an enclosed warehouse space, or it's providing large geographical coverage from high altitude platforms, or providing ubiquitous high quality connectivity in the air, like we did with SmartSky. The common thing with all of those is that there's a gap between the requirements that are needed to meet that vision. So the clients that we work with have a vision that they want to deliver their business value. It's not always wireless, but wireless is an enabling technology. And there's a gap. And how do you close that gap? You can either choose to accept what the available technology out there will give you and see if that's good enough for you as a business case, or you can choose to adapt that technology and create something that is bespoke for you. Now, if we just look at SmartSky as a specific example, so what we did with them, well, let's start with their visions. Sorry, is that they're looking to transform aviation through providing, basically they're a startup here in the US, and they're trying to provide in-cabin connectivity that is not noticeably different to the connectivity that you would have on the ground. So you think about sitting in your office or walking in the street or at home, and the kind of connectivity experience that you have using your mobile phone or your laptop or your tablet, whether that's Teamsing or emails or collaborative editing of documents, whatever it is that you're doing using connectivity, they want to provide that in the sky using an air-to-ground network, so based on the ground, and basically create that same experience in the sky that you would have on the ground. So it's completely seamless. You can, in an ideal world, you'd walk onto the aircraft, take off, and you just carry on doing whatever you were doing with no break in that connectivity. And we worked alongside them to kind of develop that vision for them, to create the technology that developed that vision. And what does that mean? So what would we mean by changing the technology? Well, for them, it's the requirements that they wanted. So they wanted to deliver the super fast, resilient, low latency connectivity to jets. You can see me in the picture there with their CTO discussing some of the finer grain kind of requirements around where antennas would be placed on a jet to get that connectivity. It's kind of one aspect where you have to really think about what you're doing. But fundamentally, what it comes down to is that cellular connectivity that we're all used to, the connectivity that's ubiquitous on the ground, is really only designed to work at kind of walking speeds and very close to base stations. So you have a high density network of base stations providing really local connectivity to people who are kind of walking relatively slowly compared to jets who travel at 600 miles an hour and are 30,000 feet above the ground at least. And because of the economics of building a network, they're probably 100 to 200 kilometers away from the nearest base station. So the technology just doesn't, the technology that exists in cellular world doesn't meet those requirements, not directly. There's aspects of it that you can delve into, that you can then make use of, but some of the, in particular, the high speed and the range, you really have to think about what can you do about adapting that technology to make it suit that use case. And so when we're working with SmartSky, we take that approach of using an existing technology, so cellular technology. It brings a whole bunch of advantages from access control, security, connectivity to the internet with packet gateways, a whole high quality, robust core network, even down to the link layer, resilience and robustness along the link layer. But primarily around the physical layer or the air interface, some of the air interfaces where the technology just wasn't quite right to meet SmartSky's requirements. So we went and adapted, and that really means making deep changes in that core technology. And because they're so deep, they have ripple effects throughout the technology that you can't just make a change and hope that it will work. But you have to do these very specific things like beamforming from the base stations to the ground, and beamforming the other way, and making sure that you can create highly complex antenna controllable beamforming control algorithms that make sure that those beams are pointed together at each other, even at 600 miles an hour, sorry. And various other optimizations such as timing and signaling of key parameters and messages to make sure that the whole system still hangs together and provides that kind of continuous connectivity in the air. And what was a result of this? So we've lived this dream with SmartSky for quite a long time, because as I say, we've had the privilege of being with them on their journey for a while. We've been proving out this technology, and last year I had the privilege of actually experiencing it for real on a flight when they launched it at the NBAA show in Las Vegas. That's the National Business Aviation Association show. So it's the premier show for business aviation. And we'd seen the promise in the labs. We've seen the technology working under emulated and simulated conditions with all the parameters being tested and thoroughly kind of ironed out in the lab. We've been on multiple test flights to make sure that it still works together when you're flying in the air. But to actually see it for real with people who would be real users of that system, taking multiple devices onto the aircraft, doing multiple things at once, trying to stream on one device while they're sending an email on the other one, really trying to flex the system and understand what does this experience feel like to them. And that was extremely gratifying just to see that and to experience it myself, to understand that it was possible by stepping outside the constraints of current technology and focusing in on the parameters that made the most value, most business value to SmartSky. We were able to create a technology that delivered that value, and that people using it really, really understood and got. And so what are the success factors? Well, fundamentally, it's about focusing on that business objective. You've got to have a bit of imagination and effort to think about what the objective is that you're trying to meet. Don't constrain yourself with the limits of current technology. But in addition to that innovation, that kind of creative thought, you've got to be rigorous and robust about actually delivering it. It's no good creating fantastic technology that solves a really intellectually stimulating technical problem if you can't deliver that into for the clients, into the marketplace, to actually for users to experience and use and create that business value. So you've got to create that technology and deliver it fitting that business objective, and be open-minded. Just don't start by saying what can't you do. It's what could you do starting from the current technology. How could you adapt that current technology to move it in a slightly different direction, or even a radically different direction, and how does that add to the value of the business objective that you're trying to achieve? So a little bit about Cambridge Consultants. Fundamentally, this is what we do, is deliver to our clients' business objectives. That's how we set ourselves up. And the way we do it is through a combination of scale, skills, facilities, and experience in delivering this high-value, game-changing technology innovation. Each project is unique because each client's requirements are unique. They require a unique set of skill sets, but we bring that same relentless drive to innovate and to make them successful. It's the combination of those two things with all the facilities and people that we have that really help us make our clients successful. We're part of a broader organization, Capgemini Event, which brings even more scale to the problems that we can solve. So we're not limited by scale of problem that we can solve, and we're not limited by domain because we have engineers, designers, scientists, mathematicians, the whole works of what it takes to create truly unique, innovative products and services for our clients. And finally, just to wrap up a bit and then open it up for questions, I just first of all, there's a link in here to this case study. There's more detail in the case study. In particular, there's some video testimonials, both from SmartSky themselves and from the project members. You can see two of the project members here working in our labs, testing some of the equipment. There's also some more detail on the specific technology that we developed with some innovations that help kind of bring it to life a little bit more. But my final thought for you is right back to the beginning. If you have an ambition that requires wireless connectivity to meet that ambition, and if the current technology solutions don't quite meet that, then come speak to us and let's think about how you can adapt current technology to move it more in the direction that you need it to move to kind of deliver that value that you want. And with that, I'll open up for questions.
Colin, thank you. That was fascinating. Really good. So there's some questions coming in. Just to be clear, just to help me out, because this is new to me. Colin, just the technology, and I don't know what you can say, but I mean, this sounds like 5G/LTE, some kind of hybrid version running in unlicensed. Is that an accurate description?
At the highest level, that would be an accurate description. So when we started on this journey with technology, of course, 5G didn't exist. So what we did, and this is a common use case for us and some of the clients we work with, is understand what elements you want to adapt to a kind of a 4G base, pulling from the industry standards out there in research, in where the trends are in the 3GPP roadmap, and understanding what features from those kinds of technologies, pulling them into that base and then adding them on. Not in precisely the same way that 5G is, but at a high level. A lot of the features you'll see will now exist as features that come with 5G. Yeah.
And there's a question here about, and as I understand it, it talks about whether it's a kind of hybrid mix of private cellular and for in-flight, and then a breakout with the national networks. Is that correct, or is this all private?
This is all private. So it's a private network that is the user experiences it as a Wi-Fi gateway in the jet, and that's all they see. The network is providing the link back down to the ground, and then the normal core network providing the link to the rest of the internet.
Okay, and you said something. I mean, there's something. I mean, in the intro about 30,000 feet in the air, which is what 10 kilometers. I don't know, more or less, give or take something. Yep. Is that about right? Yeah, I don't know, but I mean, if a standard 5G C-band kind of mid-range kind of spectrum cell tower goes a couple of kilometers, maybe 10. In a low power NB-IoT kind of low sub-gigahertz, I mean, this is quite a difference. So how is that happening? Is that with, you mentioned beamforming. There was something about massive MIMO, and just talk around that. What's going on there as well as you can, as much as you can. I said.
Yeah. So fundamentally, it's beamforming used to increase range. So beamforming on both ends. There are directional antennas that are increasing the range by essentially increasing the, not quite technically correct, but the transmit power and receive sensitivity on both ends. So yeah, we're essentially using beamform to increase the range. Yeah.
Okay, and there's a couple of things I just want to ask. We are running up on time, but just you launched October 2021. Is this commonly available, or is it done airline by airline, airport by airport? How does this roll out?
So this rolls out through the owners and operators of business jets in the US. So SmartSky are rolling it out through their customers. I think they've announced, I can't remember exactly which ones, but they've announced several of them on their website. So they are installing it on customer aircrafts and rolling out through those owners and operators of business jets. Okay,
and Colin, you mentioned that the Cambridge Consultants has done work with mobilizing 10,000 robots on what must be a factory floor or in a port or something like this. I don't know, but I mean, the rest of this session, a lot of these sessions are around private 5G for Industry 4 and vertical spectrum and all this kind of stuff. But it sounds like you've already done this. It sounds like actually you can make proprietary solutions for an enterprise already, and you don't need 5G. I mean, is that accurate? Just tell me about. Put me right.
Yes, it is accurate. It's also accurate that if 5G does meet your use case, then it probably is the best technology. So we don't push technology. We only adapt technology where it's needed. So if your use case is perfectly suited to a 5G network, a 5G private network, then that is the perfect solution.
Okay, thank you, Colin. Really fascinating. It'd be great to carry on. I've got to stop it there. We're a little bit over. We must move on. Just for everybody, if you go back to the agenda, we've another session's just starting just now about, why to start down the road to digital transformation in the first place with Siemens, the Smart Manufacturing Institute, Intel, and the International Academy of Automation Engineering. So please join us there. Thank you for now from here. Okay.